All right, so first off, we're going to start off with the disk method. Now, the disk method is probably, to me, one of the most important things because they'll say like, oh, well, we also have washers. But yeah, washers have a different formula. But in essence, a washer is just two disks being subtracted. So if you know your disk method, then you just got to do the disk method twice and just combine it, and you have your washer formula. So you don't have to worry about memorizing a washer formula if you don't want to. Just remember your disk formula, and you'll be good. So disk method is, I think I told you guys earlier, whenever the area touches the axis of rotation, we get disk. So they give us a formula for this, okay? Let's put horizontal rotation here, horizontal rotation. And we get this formula for it. V equals to pi integral from A to B of f of x quantity squared dx. Now f of x is going to be the function that they give us, okay? So it's just going to be f of x quantity squared. Now actually, sometimes people say like, oh, wait a minute, isn't it supposed to always be a subtraction of two things? Because to find the area underneath a curve, we always subtract, right? So let me kind of give you an idea why this thing doesn't have a subtraction of 2. It actually does, but we don't write it. But let me show you. So if I were to draw a graph that looked like this, and I tell you that this is a disk, okay? So if I tell you that this is a disk, I'm just going to go from A to B right here. And here's the area of it. And this thing is being bounded by the function, by A, B, and by the x-axis. Okay, we're going to make our x-axis our axis of rotation. That's where we're going to spin it. So here's the area that they're talking about. And we're going to spin that around. Now you'll notice that this area touches the axis of rotation. You guys see that? It's touching, right? So my top function is f of x. Okay, here are my two functions right there. F of x. G of x is represented by the x-axis. What's the formula for g of x? If it's the x-axis, g of x equals 0. So the area is f of x minus g of x, right? That's how we find area between two curves, right? Top minus bottom. Well, if g of x is 0, then the area found in there is just f of x. You guys see that? It's just f of x because g of x is 0. Okay? So for this equation right here, you're going to say v equals to pi integral from a to b of f of x squared dx if g of x equals 0. But if it doesn't equal to 0, then you're going to write v equals pi integral from a to b of f of x minus g of x quantity squared dx. Notice how it's basically your area formula that you learned in 7-1, okay? But we're squaring it, f of x minus g of x squared, and then instead of just integral from a to b, we're putting pi in the front, okay? So there's a pi now, and we're squaring the area, okay? And the reason why we say, like, what if g of x is not equal to 0? And I guess I could put right here, if g of x is not equal to 0. Because it depends on the axis of revolution. If the axis of revolution or the axis of rotation happens to be like a 2 or a -3, well, then you do have to subtract that. You can't just ignore it. Okay, you do have to take that into consideration. So that's our disk method. For horizontal, for vertical, it's the same idea, just we change a little bit of the variables that we're using. So let me write this down here. Vertical rotation So in other words, if your axis of rotation or your axis of revolution is vertical, so you're spinning it around this way, okay, then you'll get something like this. V equals to pi integral from C to D. Remember, we changed C to D because that's thought of as being a vertical representation going up, down. AB usually goes left to right, so CD would be up and down, okay? And then you just do f of y squared dy. Okay, that's if g of y equals 0. Now draw a picture so you guys can see this. So let's see. Say that's our function. They want us to go from C to D. They want us to have an axis of revolution that's the x-axis. So if we have the x-axis as our axis of revolution, that means that g of y would be 0, right? That's the way you would write that equation, x equals 0. Our area that we're going to be marking off is this piece right here. Okay, so this is going to be going around in circles. And notice how the area is touching the axis of revolution, so it's going to create a disk. It's going to close off the hole. Okay, just like the one that we had up here, right? The yellow marking was touching the axis of revolution, so it's going to create a solid disk. Okay, so that's if g of y equals 0, then when you rotate it, right, the area is supposed to be, according to definition, we'll call this f of y and g of y. Okay, I'm just using these arrows to point out the two functions. Okay, that's all I'm doing. So you're supposed to do right minus left, right? F of y minus g of y. But if g of y is 0, sorry, not equals 0, then that means that that area is just f of y, right? But that's only if your axis of revolution is at 0, then they're trying to get you to do that. So we also got to write the definition if it's not 0. So it's the same thing. We're just going to include the g of y now. So f of y minus g of y squared dy if g of y is not equal to 0. Now this seems kind of weird and confusing. Like I said, hopefully the way I teach it for you guys will make a lot more sense. I use a lot of pictures. Okay, I use pictures so that it makes it more obvious as to what we're doing. And I mark up those pictures so you can say, oh, here's top, here's bottom, from here to here. And then the next picture, oh, here's top, here's bottom, from here to here. And you can write your equations really easily. I know some people think this is some of the hardest stuff in calculus to do. I think it's actually some of the easiest stuff to do if you can visualize it. Okay. The way I learned it using formulas and radii and stuff like that, it was a little weird, you know, but I mean, I understood it. It's just, it was a little weird. I try not to do that. I try to do my best to give you guys something that you can see visually so it makes sense. So, anyway, that's the definition of a disk. Now, once we understand the definition of a disk, then the definition of a washer is really easy, because it's not much more different. There's a different formula, but like I told you, you don't really have to memorize the formula if you know how to use disks. Because when you draw your picture, you're going to basically do disk minus disk, and that's a washer. Okay? So to me, that's why I like this stuff, because I'm like, well, I don't have to actually learn. There's actually a shell method too, but I don't actually learn like all 3 equations. I just got to learn 1, and the 1 helps me do all of them. Okay? But lucky for you guys, shell method is not included in the A/B test, so you don't have to worry about that. So here's an example. So example number 1, we're going to find the volume of the solid find the volume of the solid formed by revolving the region bounded by the graph of and here are two graphs. F of x equal to radical sine x and the x-axis from 0 to pi, and then they're going to say this word here, about, which means get ready to know where your axis of revolution is going to be. So you say about the x-axis. That means that I'm going to be spinning this thing about the x-axis. So that's going to be my axis of revolution. So we're going to have to draw this. Okay, I mean, do you have to? I guess not really, but if I were you, I'd draw it. It doesn't have to be perfect. Use your graphing calculator, whatever you want. But let's draw this out. So they said from 0 to pi. So 0, we'll say pi. Now the fact that it's a radical sine of x doesn't really change the picture of sine of x. It's still going to look like this. It starts at 0, it goes up, and back at pi, it goes back to 0, right? Normal sine of x, it goes 0, 1, 0, negative 1, 0, right? 0 at 0, 1 at pi over 2, 0 at pi, right? So that means it's just going to do this. Is that the right graph? I don't care. It looks like it. Okay, and like I said, you guys can get your own graphing calculator and check it and stuff. It's going to look something like this. Okay, and right here there's a pi over 2. That's a high point. The high point is going to be at 1 anyway, but there you go. Okay, so there's my picture. Now they want me to revolve it around the x-axis, so I'm going to put that little arrow right there, saying like, look, I'm going to spin it this way. Okay, so since the area is touching the axis of revolution, this is a disk. Okay, this is a disk. And it's going to kind of form like, I guess you can think of like a rugby ball, maybe not so much a football, but maybe, or it might be look more like a football depending on what the exact graph looks like. But it's going to form something like that shape, okay? Once it starts to spin, that's the solid we're thinking about, right? Like a football, okay? That's what it's going to look like. So how do I go about doing this? Well, I got to first identify my functions, okay? F of x is radical sine of x. What's my g of x? What's my bottom function for this area? 0, right? G of x is 0. That's my bottom function. What's my a to b? 0 to pi, right? So all I got to do then, I'm going to pretend that I'm not doing the 0 definition formula. If I were you, I'd always do the what if g of x is not 0? And then you'll find out, oh wait, it is 0, and you'll fix it, okay? But if I were you, I'd do it like this. Volume equals pi integral from a to b of f of x minus g of x, quantity squared, dx. By the way, I know this is a g of x and a f of x and a d of x function because my axis of revolution is horizontal, right? It's going this way. It's spinning it on the horizontal axis, okay? So I know I got to use this formula. If it was spinning it vertically on a vertical axis, then I have to find g of y, f of y, dy. I got to solve for x on my original equations. Here I'm going to leave it the way it is. Now let's fill in the information. V is equal to pi integral from 0 to pi of radical sine of x minus 0, right? Top minus bottom. Notice that doesn't change from the area stuff that we were doing before. You either do top minus bottom or right minus left. That doesn't change. So that's why they teach you 7-1 first, because they're like, take that and use it for this. Okay, use the same ideas, top minus bottom, or maybe right minus left if you're doing a vertical rotation. So I got it squared. I forgot to put a square up there. Sorry about that. So volume is equal to pi integral from 0 to pi of, well, radical sine of x minus 0 is just radical sine of x. And if I square it, I just get sine of x. And now I can integrate it, right? So volume is equal to, now the integral of sine of x will be a negative cosine of x. So pi negative cosine of x from 0 to pi. What I'm going to do is I'm going to take that negative out, okay? I'm just taking an extra step. I'm moving the negative out. Remember, you can do that. You can factor a number. A scalar is fine. You just multiply it back in later. So let's see. Volume is equal to negative pi cosine of pi minus cosine of 0. Well, what's cosine of pi? Negative 1. What's cosine of 0? 1. So we get negative pi, negative 1 minus 1. So volume is equal to, well, that's a negative 2, and there's a negative pi outside, so it should be 2 pi. And that is the volume for that solid that gets formed when you spin it around. Okay, you got a 2 pi. I mean, does this seem like insanely difficult? I mean, hopefully not. I know it might seem a little weird at first, but notice I labeled my picture, and from that picture, I got all the information I needed to plug in. Okay, and I know the pictures might get a little more complicated, which I'm hoping they do. I know the next one is still not going to be super complicated, but we'll get to something a little more complicated. But it's all based on your drawing. You want to draw a good picture. If you get a good picture, I think it makes it easier for you to do the work. Okay? So, any questions on this one? Because we got another example. Are we okay? All right, so let's see. Example number 2. So find the volume of the solid. Find the volume of the solid formed by revolving the region bounded by and here we go. They give us f of x equals 2 minus x squared, and g of x equal to 1 about y equal to 1. So again, there's that word about, right? That means here comes your axis of revolution. Y equals 1 is where we're going to be rotating. All right, so let's draw this thing. All right, so they said y equals to 1 is going to be my axis of rotation. I'm curious if I should do this. I'm just going to keep it at normal units. So it's going to be 1, 2, 3. So just basic units of 1 as I go across. The picture may not end up as big as I'd like it to, but it's okay. All right, so let's see. They said the graph of f of x equal to 2 minus x squared. So 2 minus x squared, I got to go up to 2, and it's going to look like this. So there's 2 minus x squared. They said g of x equal to 1 is my second graph. So g of, that means y equals 1. So it's right here. That's y equals to 1. And they said, and you're going to rotate it about y equal to 1. So my axis of rotation is about that line. Okay, so there's the area right there. Notice I'm rotating horizontally. I know it sounds weird because I'm going up and down when I do my hand motion, right? Horizontal, I'm doing this, but what I mean is that the line is horizontal, therefore it has to go above and below it this way, right? So I'm rotating horizontally, which means I got to do top minus bottom. What's my top function for that yellow area? Is it the red or the blue? The red, right? For the yellow area, it's the red one. So the red one would be f of x equal to minus x squared. What's the bottom function for that yellow area? What's the function that seals it off on the bottom? Yeah, just y equals 1, right? Or g of x equals 1. So I'm right, g of x equal 1. That's my bottom. So f of x minus g of x will be 2 minus x squared minus 1, right? That's what's going to go inside. Now, the thing they didn't tell us in this problem that they told us in the other one was what? What's missing here? My what? My boundaries. I don't know from where to where. Well, I actually do because I drew this pretty perfectly. But if I didn't draw it nicely, what are you going to have to do to figure out your A to B? Yeah, set them equal to each other. So 2 minus x squared equals to 1. So I'll just move the, well, I can move the 1 over really quick, and then I'll move the x squared at the same time. So 1 is equal to x squared. So x is equal to plus or minus 1. So they intersect at these 2 points. And I did try my best to draw it so that they did, okay? But they intercept at -1 for x and +1 for x. So that gives me my formula now, okay? Volume equals to pi integral from -1 to 1 of f of x minus g of x, 2 minus x squared minus 1 squared dx. All right? Everybody okay with that setup? So again, you got to look at your picture. Say, okay, top was the red. The red is represented by f of x. So it's top minus bottom. So f of x minus g of x, which is the bottom function, that's equal to 1. So I just plug it in. So volume is equal to pi integral -1 to 1 of 2 minus 1, that's 1 minus x squared dx. By the way, you can do this. You can do this on your calculator, but sometimes it's nice to get a little practice by hand. Okay, but once you get to this point, you guys can plug it into your calculator and be done with it. But yeah, what if you can't use a calc? Well, then it's good to practice. So let's expand that because I can't integrate the way it looks like right now. So it's 1 minus 2x squared plus x to the 4th dx. If I expand 1 minus x squared squared, okay? Because that's basically 1 minus x squared times 1 minus x squared. So now we can integrate. And again, this is a lot faster when you just plug it into a calc. X minus 2x cubed over 3 plus x to the 5th over 5 from -1 to 1. And now plug in your numbers and work it out. So volume is equal to pi. For the 1, we're going to get 1 minus 2/3 plus 1/5. And then for the -1, we're going to get -1 plus 2/3 and then minus 1/5. So volume is equal to 1 minus a -1, that's a 2. -2/3 minus 2/3, that's a -4/3. And a 1/5 plus a 1/5, that's a 2/5. Now, if you combine all that stuff together, okay, so 2 minus 1 1/3 plus 2/5 times pi, you get 16 pi over 15. Notice these are just big integration problems. That's all they are. But you do have to set them up properly. Okay, you do have to set them up the way they're supposed to be. So I know we're kind of early. We have like 17 minutes. So what I'm planning on doing, I don't want to introduce washers to you guys yet, even though I think you're ready. But I'd rather give you guys some homework to work on with discs. So that way you can give me a little bit of time to do that right now before you guys leave. And then you can start here. Okay, just some basic disc problems, no washers involved. And then tomorrow we'll do washers, and at that point we're gonna give you homework for that.